Hi, welcome back to Precalculus. We're still in Chapter 8. Now we're on Section 6, the Algebra of Matrices. So we're going to dive right into some vocab, bang out some addition and subtraction, and get straight to the nitty-gritty real quick here. So let's start speaking the same language. A sub ij represents an element in a matrix. The subscript I represents the row that element is in. And the subscript j represents the column that element is in. Another name for the size of a matrix is the order of the matrix. Okay, so you can see matrix A right here. The size of it would be a 2 by 3. It has 2 rows and 3 columns. Rows being horizontal, columns being vertical. So the element in that matrix, A sub 1, 3, not A sub 13, A sub 1, 3, is in matrix A, row 1, column 3. Row 1, column 3, that is element 5. In matrix A, rows 2, column 2 is element 3. In matrix A, row 2, column 1, row 2, column 1 is a 0. We go over to B, we see B is a matrix that is a 3 by 2, 3 rows and 2 columns. Row 1, column 1 is a 6. Row 2, column 1 is a 45. And row 3, column 2 is a 99 in that matrix. So, jumping straight into addition and subtraction. So in order to add or subtract matrices, they must have the same dimensions or the same order. Matrix addition is commutative, meaning the order doesn't matter, and it is also associative, meaning grouping does not matter. So in order to add together two matrices, I got a whole bunch of different matrices right here. In order to add together matrix A plus matrix B, you simply add together the same elements. So matrix A is a 2 by 2, matrix B is a 2 by 2. They got the same size, so I know I'm going to be able to add them together and get a 2 by 2. Let's put some blanks in there. Okay, now taking A sub 1, 1 and adding it to B sub 1, 1. Negative 2 plus 4, 2. A sub 1, 2 plus B sub 1, 2. 1 plus 3, 4, and so on. 3 plus 6 is 9. 4 plus 1 is 5. Doing B minus A, very similar, the same matrices, same dimensions, so I know it's possible. B minus A is going to yield a 2 by 2 matrix. B, 4 minus negative 2 is 6. 3 minus 1 is 2. 6 minus 3 is 3. 1 minus 4 is negative 3. B plus C, now C is a 3 by 3 matrix. It's impossible because the order is not the same. The size does not match. So let's go ahead, and let's jump to some scalar multiplication now. We are able to multiply every number in a matrix by a constant, or what we will call a scalar. Seen here, we're multiplying matrix E by 1/2, so we're taking every single element in matrix E and multiplying it by 1/2. So negative 2 times 1/2 is negative 1. Negative 1 times 1/2 is negative 1/2. 3 times 1/2 is 3/2. 0 times 1/2 is, of course, 0. 1 times 1/2 is 1. 2 times 1/2 is 1. Doing 2c minus 3d. Well, let's see here. We can multiply 2c, or we can multiply 2 times that, and 3d. So these are both 3 by 3 matrices. Okay? First, we need to follow our orders of operations and scale the matrices before we subtract. So C is going to be twice as big, and D is going to be 3 times as big. Let's go ahead and double every single number in C. 4, 2, 6, 2, 0, 4, 8, 2, -2. Every element in D needs to get tripled. So 6, 15, 3, 12, -3, 3, 0, 9, -6. And now let's go ahead and subtract it. Well, -4 minus 6 is -10. 2 minus 15 is -13. 6 minus 3 is 3. 2 minus 12 is -10. 0 minus -3 is 3. 4 minus 3 is 1. 8 minus 0 is 8. 2 minus 9 is -7. -2 minus -6 is 4. Now, we can continue the process and everything. 5b plus a, we know that's going to be possible because they have the same dimensions. We're going to be able to add them together after scaling b by 5. 4c plus e, we can quadruple c, but we can't add a 3 by 3 to a 3 by 2. So that's impossible. Sorry about that, just a quick interruption from our great principal, Mr. Carroll. But I want to show you guys real quick how to do 5b plus a on your graphing calculator. So go ahead, turn your graphing calculator on, and let's go to second matrix. And we are going to edit, so go to the right arrow, we're going to edit matrix A, and we are going to change matrix A to be a 2 by 2 matrix. Okay, so we want to go ahead and put matrix A in. So matrix A is -2, 1, 3, 4. 3, 4. And we want to quit out of there and go back and edit matrix B. Matrix B is also a 2 by 2 matrix. 4, 3, 6, 1. Now that we have all of our matrices in there, we can quit out of there and we can get the calculator to do 5b plus a for us. So let's go. First, let's press 5. Second matrix, we want to select matrix B. So let's select matrix B plus, it's back in our matrix menu, matrix A. And if we hit enter, notice it will give us 18, 16, 33, 9. You can get your calculator to do a lot of the work for you. It's really, really, really handy dandy. Okay, so let's go straight into multiplying matrices here. In order to multiply matrices, they must have the same inside dimensions. For example, you can multiply a 3 by 5 matrix by a 5 by 1 matrix, but you cannot multiply a 5 by 1 matrix by a 3 by 5 because the inside numbers match here. They're both 5s, whereas here one's a 1, the other one's a 3 that don't match. So if we were to multiply a 3 by 5 times a 5 by 1, the resulting matrix is the outside dimensions. So the first example would result in a 3 by 1 matrix. When you multiply, you take each element in a row times the corresponding elements in a column, and you add those numbers together to get a new element. We'll call it product I sub j, just like A sub j. Okay, so let's go ahead and multiply A times B if it's possible. So let's check it out. A is a 2 by 2, B is a 2 by 2. They have the same inside matrices or inside dimensions, so the resulting matrix is going to be a 2 by 2. I'm going to make it really big here so I can write out each element for us. Now, to figure out what element is in row 1, column 1, we multiply row 1 times column 1. So negative 2 times 4 plus 1 times 6. Row 1, column 2, negative 2 times 3 plus 1 times 1. Row 2, column 1, 3 times 4 plus 4 times 6. And lastly, row 2, column 2, 3 times 3 plus 4 times 1. Now it's just some simple arithmetic. Negative 8 plus 6, negative 2. Negative 6 plus 1, negative 5. 12 plus 24, 36. 9 plus 4, 15. Now notice these are the same as we used before, so they're already fresh in our calculator. Let's just get our calculator and see if we can do A times B. So let's take a look here. Let's go ahead and select matrix A. Times matrix B. Hit enter. Negative 2, negative 5, 36, 13. So we know it works. Now let's go ahead and clear our screen and do the next example, which says B times A. Let's just go ahead and let our calculator do that for us. Since we already know the process, B times A. And you notice A times B gave us a different matrix than what B times A gave us. 1, 16, negative 9, 10. So let's take a look at those now. Two totally different answers. So matrix multiplication is not commutative, whereas in numerical multiplication, 5 times 3 is 15, 3 times 5 is 15. Regular multiplication is commutative. Matrix multiplication is not commutative. Okay? A squared is the same as A times A. So a 2 by 2 times a 2 by 2, the inside dimensions match. So we're going to be able to do it. Let's go ahead and get our calculator to do it for us. On my screen, there we go. So second matrix A, and we can go ahead and square it just like square any other number and get the answer 7, 2, 6, 19. Now let's take a look at multiplying C times D. A 3 by 3 times a 3 by 3. We know is going to be possible. I encourage you to check your calculator, input C, input D, and multiply C times D. If possible, we know it's going to be possible, and so is D times E. So let's go ahead and do that and close out our lesson for the day. So let's plug in matrix C, second matrix, edit, matrix C. We want it to be a 3 by 3, so negative 2, 1, 3, 1, 0, 2, 4, 1, negative 1. And now we have to quit out of there, so second quit. Let's go back and edit our matrix D, which is also a 3 by 3, 2, 5, 1, 4, -1, 1, 0, 3, -2. Now that everything's in there, quit out of there, clear my screen, and I can multiply matrix C times matrix D. So there we go. And get the answer 0, -2, -7, 2, 11, -3, 12, 16, 7. Hope the notes were fast and easy for you. I look forward to working with you in class, and if you have any questions regarding the calculator or matrix addition, subtraction, scaling, or multiplication, feel free to ask. See you tomorrow.